In this problem, we have to solve this trigonometric equation. So we'll start by trying to isolate the sine function. So we'll add 6 to both sides. So plus 6 plus 6. That'll give us 5 times the sine of x. And that's going to be equal to 6. So to finish solving for the sine function, we'll just divide by 5. So divide by 5, divide by 5. So we end up with sine x equals to 6 over 5. And this is where we are done. If you think about it, the sine function has a range between -1 and 1. You know, the maximum value that sine can be is 1, and the minimum is -1. 6 over 5 is bigger than 1, so there's no way the sine of x is going to be equal to 6 over 5. So the answer is that there is no answer. There is no solution to this problem. If your question is asking for the solution set, it would be the set containing nothing. So it's a set with no numbers. In other words, the empty set. I hope this video has been helpful. In this problem, we're going to solve this trigonometric equation. So we'll start by isolating the cosine function. So because we're adding a 5 here, we can subtract 5 from both sides. So minus 5 and then minus 5. So these cancel. So we have 3 cosine x equals minus 5. Okay, and now because it's being multiplied by 3, we'll divide by 3. So divide by 3, divide by 3. That gives us cosine of x equals -5 over 3. And we're actually done. And the reason is this is a number smaller than -1. If you think about the graph of cosine, it looks something like this. It's a wave function. It's a pretty bad picture, but the biggest it can be is 1, and the smallest is -1. So this is a number smaller than -1. So there's no way the cosine function will ever be equal to that, because the smallest it can be, according to the graph, is -1. So the answer here is that there is no answer. There is no solution. If you wanted to write your answer in set notation, you would do this. You would write the set, and then there are no answers, so you put nothing there. This is called the empty set. Or if you like, you can put a circle and a dash through it, and that would be the set of solutions. I hope this video has been helpful. In this problem, we have to solve this trigonometric equation. So we have 2 sine x plus 1 equals 0, and x here is between 0 and 2 pi. So in this case, all we have to do is isolate the sine x. So we'll start by subtracting 1 from both sides. So -1 minus 1. That puts us at 2 sine x equals -1. We're almost there. To finish solving for sine, we simply have to divide by 2. So divide by 2, divide by 2. And so we have that the sine of x is equal to -1/2. So now we have to think back to some trig knowledge. When you look at -1/2, you really want to think about 1/2 and ask yourself, what is the angle such that the sine of that angle is 1/2? So from memory, we know that the sine of pi over 6 is equal to 1/2. So the sine of any angle that has a reference angle of pi over 6 is going to be 1/2, or it's going to be -1/2. So now we have to think about the unit circle and think about all of the other angles that have a reference angle of pi over 6 that will give us a negative. So let's think about that. So if it's going to be negative, remember that sine is the y coordinate on the unit circle. That means the angle has to be down here and it has to be down here. So we're looking for angles here because sine is the y coordinate on the unit circle. And these are angles whose reference angle is pi over 6. So this is pi and this is 2 pi. So if you want a reference angle of pi over 6 down here in quadrant 3, what you need to do is you need to add pi over 6. So think of pi as 6 pi over 6. And so the first angle we want would be this one. 6 pi over 6 plus pi over 6 will give us 7 pi over 6. So x equals 7 pi over 6 is one of our answers. The other angle is over here in quadrant 4. So again, think of 2 pi as a number over 6, so 12 pi over 6. So if you take 12 pi over 6 and you want this angle here to be pi over 6, that's our reference angle, then you need 11 pi over 6. You just subtract. So 11 pi over 6. So the other answer to this problem would be 11 pi over 6. And that's it. I hope this video has been helpful. In this problem, we have a trigonometric equation and we're being asked to solve for x. So whenever you have a trig equation, and it's not just like sine x or cosine x, whenever it's something besides x inside the trig function, the approach is the following. You start by writing this down. So we have that x is less than 2 pi and is greater than or equal to 0. So write it down like this. And then you want to manipulate this to make it look like what's inside your trig function. So let's go ahead and divide each piece by 2 because we're trying to get to x over 2. So divide by 2, divide by 2, divide by 2. So we get 0 less than or equal to x over 2 less than, and then these cancel, so you get pi. And so now what we can do is we can rename this x over 2 just for convenience purposes. We can call it u. So we really have 0 less than or equal to u less than pi. And so now our equation gets transformed, right? It's actually sine of u equals cosine of u. And this just makes it so much easier to think about. So now we're looking for the solutions to this equation. So when is sine u equal to cosine u when u is between 0 and pi? So if we think about the unit circle and the values that we know of sine and cosine, we know that the only time they're the same involves the angle pi over 4. They're the same at pi over 4, which is here. And they're also the same when they're both negatives. That's going to be over here. So this will be 5 pi over 4. So those are the two angles where sine and cosine will be equal. In all cases, in both cases, they'll be equal to the square root of 2 over 2, right? The sine of pi over 4 is square root of 2 over 2. So is the cosine of pi over 4. So is, and then in this case here, sine of pi over 4 is negative root 2 over 2, and cosine of pi over 4 is also negative root 2 over 2. So in both cases, these are equal. However, this is pi, and this is 0, so we don't want this angle. So the only angle we want is pi over 4. That means that u must be equal to pi over 4. But we're looking for x, so now what you do is you go back and you replace your u with what it actually was. Remember back here, we said that u was x over 2. So that means x over 2 is equal to pi over 4. But now we're looking for x, so you just multiply both sides by 2, multiply by 2, boom. So we get x equals pi divided by 2. And that should be the only solution to this equation. I hope this video has been helpful. In this problem, we're going to solve this trigonometric equation, and we have a restriction on x. X has to be between 0 and 2 pi. Okay, so since we only have one trig function, tangent, in this problem, let's start first by isolating it. So we have a plus 1 here, so we can get rid of it by subtracting 1. So let's do that first. That gives us 2 times the tangent of x, and that's equal to negative 2. All right, so we're almost there. The tangent function is being multiplied by 2, so now we can just divide by 2, divide by 2. So we have the tangent of x, and that's equal to negative 1. And now we have to keep in mind that we are in this interval here. So we're looking for all of the values of x in this interval here, such that tangent of x is equal to negative 1. So if you don't have stuff memorized, it's okay. As long as you remember that it's sine over cosine, and that's equal to negative 1. From this, you should be able to do it using some stuff about sine and cosine. So if you don't have all the angles for tangent memorized, no worries, we can do it just by thinking about sine and cosine. So if you divide sine and cosine and you get -1, that basically means they're opposites, right? Like one is positive, the other is negative, and they're the same number. So on the unit circle, cosine is the x-coordinate, and sine is the y-coordinate. And you know that at like pi over 4, they're the same, right? Pi over 4, you get square root of 2 over 2. And so at all the other angles that have a reference angle of pi over 4, they're either going to be, you're either going to get square root of 2 over 2 or negative square root of 2 over 2. So think about, when are the x and y, when do they have opposite signs? Well, here, right here, x is negative and y is positive. And so the angle here, that's a multiple of pi over 4, that has a reference angle of pi over 4 rather, would be 3 pi over 4. That's because this is pi and this is 4 pi over 4. So if you subtract 1 from 4 pi over 4, you get 3 pi over 4. So one answer is 3 pi over 4. The other place that they're opposites would be over here, this green arrow. So this is this angle here. And that's because the x-coordinate is positive and the y-coordinate is negative. And so this is 2 pi. So if we think of this as an angle over 4, that would be 8 pi over 4. So if you want a reference angle of pi over 4, you just subtract pi over 4 from 8 pi over 4. That'll give you 7 pi over 4. And that's our other answer, x equals 7 pi over 4. So these problems require a ton of information, even the simple ones like this. I mean, for this one, we had to use the fact that we know that the sine of pi over 4 is equal to the square root of 2 over 2, but that's also equal to the cosine of pi over 4. Then we had to use reference angle knowledge to note that, you know, over here at 3 pi over 4, one of them is negative, one of them is positive. Here at 7 pi over 4, one is negative and one is positive. And when you divide them, you just get -1. So that's what we want. We want the values of x such that sine and cosine are opposite numbers. And those x values would be 3 pi over 4 and 7 pi over 4. I hope this video has been helpful. Good luck. In this problem, we have a trigonometric equation. We have cosine squared minus sine squared, and that's actually equal to 1. So let's go ahead and try to work through this solution. So it would be really nice if the right-hand side was a 0, because we know that the left-hand side is the difference of squares. So you can write this as cosine x minus sine x times cosine x plus sine x. But it's equal to 1 on the right-hand side, so it's not really going to help us. So instead, what we're going to do is we're going to use a trig identity. So cosine squared minus sine squared is the same thing as cosine of 2x. And this is equal to 1. Okay, so now we're carefully going to solve this. So the issue here is that there is a 2x. Okay, so let's think about where x is. X is between 0 and 2 pi. So let's write that down. Less than 2 pi, greater than or equal to 0. By the way, this strategy, what I'm doing here, like writing this down, whenever you have like a 2x or like a 3x or something besides x and it's equal to a number, and you're trying to solve an equation like this, do this, right? Do what I'm doing like this. Put the x between these numbers, and then what you do is you make this look like what's inside your trig function. So we have a 2x here, so now we're going to multiply everything by 2. So 2 times 0 is 0. 2 times x is 2x. 2 times 2 pi is 4 pi. So now we're thinking of, okay, what are all the answers between 0 and 4 pi? That's how it works. So we're looking for all of the values of this, of 2x. You can call it u if you like. If you like, you can do this and let u equal 2x. So all of the values of u, where u is between 0 and 4 pi, such that the cosine of u is equal to 1. Okay, let's think about the unit circle. Here's 0, here's pi over 2, here's pi, here's 3 pi over 2. So here's our unit circle. And so on the unit circle, every ordered pair can be written as cosine theta, comma, sine theta. Every single one. So we want the places where the x-coordinate is 1. That's going to be here and here. No, it's going to be here, 1 comma 0, and that's it. I think this is the only place. Yeah, this is the only place where the x-coordinate is going to be 1. So the only angles would be 0. So u equals 0. And then, again, we're going between 0 and 4 pi. Another angle would be 2 pi, right? This is also 2 pi. You might say, well, what about 4 pi? Well, 4 pi won't work because we have a strict inequality. So these are the only two angles between 0 and 4 pi where the cosine is equal to 1. And so that would mean that 2x is equal to 0, and also that 2x is equal to 2 pi. So that means that x is equal to 0 and x is equal to pi, right, dividing by 2. And that would be the final answer. Find all solutions to the following equation. 2 times the sine of x minus 1 equals 0. Let's go ahead and work through this. So we'll start by isolating the sine of x. So to do that, we will add 1 to both sides. So plus 1, plus 1. So these cancel, and we have 2 sine x equals 1. So now the sine function is being multiplied by 2. So to get rid of it, we'll divide. So divide both sides by 2, divide by 2. So we have sine x, and that's equal to 1 over 2. So the question says to find all the solutions. So what we'll do is the following. We will first find the solutions in the interval 0 to pi. And then, since the sine function has a period of 2 pi, we'll add 2 pi to each solution. But the thing is, you can actually add 2 pi multiple times to get more and more solutions because the period is 2 pi. So what we'll do is we'll add 2k pi to all of our answers here. So we'll actually have infinitely many solutions. So basically, we just solve this equation with this restriction, and then we add 2k pi, and that gives us all of the other solutions. So to solve this, we have to use memory. So we're looking for x, and the sine of x has to be equal to 1/2. So that value of x is pi over 6. This is just from pure memory. So we're memorizing this one. So now we have to ask the question, what is the other angle in this interval here such that the sine of that angle is equal to 1/2? Well, we know that the trig function values of an angle are the same if the two angles have the same reference angle. So they're the same except for possibly a sign difference. So plus or minus the same answer. So the sine function is the y-coordinate on the unit circle. So this is the unit circle, cosine is the x-coordinate, sine is the y-coordinate. So the y-coordinate is positive here and here. So we know this first angle here must be pi over 6, right? Because this is pi over 2 and pi over 6 is smaller. And so now the answer is going to be this other angle over here. So let me use a different color. Let's use this color here. So we're looking for this angle here. So this angle has to have a reference angle of pi over 6. So here's the reference angle, this tiny little angle which I drew. That's pi over 6. So what is this angle here? Well, this is pi, which is the same thing as 6 pi over 6. So it's pi over 6 less. So this will be 5 pi over 6. Really tricky, right? It just takes a lot of practice. So x is equal to 5 pi over 6. Again, the trig function values of an angle and its reference angle are the same except for possibly a sign, so like plus or minus. For example, the sine of 7 pi over 6, right? 7 pi over 6 would be down here because it's a little bit bigger than 6 pi over 6, so pi over 6 more gives us 7 pi over 6. And this also has a reference angle, which I'll indicate in blue, of pi over 6. So the sine of 7 pi over 6, it's going to be 1/2 or negative 1/2. But since sine is the y-coordinate on the unit circle, and y is negative in quadrant 3. This is negative 1/2. So same reasoning, right? Same idea. Okay, now that we have these, to get all of the answers, we simply add 2k pi and then 2k pi. And just to explain this point a little bit more, let's say we're just focusing on pi over 6. So here we are at pi over 6. Well, we know if we make a full revolution around the unit circle, which is 2 pi, we're going to get back to the same place. So pi over 6 plus 2 pi is another solution to this equation. And if we do it again, we would be adding 4 pi. That's where the k comes in, right? Basically, you add any multiple of pi. You can subtract or add 2 pi as many times as you like, and you're going to get to the same place. And then that's what the k is for. It lets you add or subtract it as many times as you like. The last thing maybe we should say here is k is an integer. Probably worth mentioning that. So a little bit trickier because we had to find all of the solutions. I hope this video has been helpful. Good luck. In this problem, we have a function, negative 2 times the cosine of x plus 1, and we're being asked to solve this equation and these inequalities. We're also told that our interval is 0 to pi. Let's go ahead and work each of these out. So solution. First, let's do part A. So to do part A, we basically take the function and set it equal to 0. So negative 2 cosine x plus 1, and this is equal to 0. All right, because we have a single trig function, it's not so bad. We can subtract 1 from both sides. So we have negative 2 cosine x, and that's equal to negative 1. Because the cosine function is being multiplied by negative 2, we can undo that by dividing by negative 2. Divide by negative 2. So we have cosine of x, and that's equal to 1 over 2. All right, so now we just have to think, what are the values of x such that the cosine of x is 1/2, where we're between 0 and 2 pi? Well, one obvious answer from memory, this is just from memory, is pi over 3. That's one of the answers. Now we're looking for another angle. Okay, another angle where the cosine of that angle is 1/2, and that angle has to have a reference angle of pi over 3. So now you think, okay, this is positive. So where is cosine positive? Right here at pi over 3, and then right here in quadrant 4. So what is the angle that is in quadrant 4 and has a reference angle of pi over 3? Well, if this is your reference angle, right here, pi over 3, what is this angle here? That's the answer. Well, to figure it out, just think of 2 pi as an angle over 3. So 2 pi is actually 6 pi over 3. So you just take 6 pi over 3 and you subtract pi over 3, and that gives you 5 pi over 3. So the other angle is x equals 5 pi over 3. Okay, so now we can do the other parts, part B and part C. To do these, I'm going to rewrite our function down here since I scrolled down and lost it. So f of x is equal to negative 2 cosine x plus 1. And I'm going to draw a number line. So here's our number line. And then we're including 0. Actually, we're not including, it's a strict inequality, so but I'll include it just in case. And then we have 2 pi here. Yes, we might actually use 0. And we plot our numbers, so pi over 3, and then here we have 5 pi over 3. Then you just pick test points. You can pick any number you like, and then you just figure out if it's positive or negative. So for example, a nice number between 0 and pi over 3 would be pi over 4. That's smaller than pi over 3. So let's plug it into our function. F of pi over 4 is equal to negative 2 cosine of pi over 4, and then plus 1. So that's negative 2 times the square root of 2 over 2 plus 1. So that's negative square root of 2 plus 1. That's negative because the square root of 2 is bigger than 1. So this is going to be negative. I was going to put neg negative. How about a nice number between 0 and between pi over 3 and 5 pi over 3 rather. How about pi over 2? So f of pi over 2, that would be negative 2 cosine pi over 2 plus 1. And the cosine of pi over 2 is 0, so this would be negative 2 times 0 plus 1, so you just get 1. So this would be positive. And last but not least, we need an angle between 5 pi over 3 and 2 pi. I'm thinking maybe something like 11 pi over 6 is probably the best we can do. And let's see, that would be negative 2 cosine 11 pi over 6. Falling off the screen here, plus 1 equals negative 2. The cosine of 11 pi over 6 is the square root of 3 over 2. And that's plus 1. So that's equal to negative root 3 plus 1. And root 3 is bigger than 1, so this is negative. So did that pretty fast. You can use a calculator, I guess, to do all of this. Most people probably do. So now we can write the answers where it's less than 0. So for part B, it's less than 0. So that would be bracket 0 to pi over 3. And also 5 pi over 3 to 2 pi. And then for part C, that's where it's positive. That would just be pi over 3. Rather where it's negative. Oh, I did them backwards. So this would be, this is part C. And this is part B. And then positive would be pi over 3 to 5 pi over 3. Right, this is negative. And this is positive. And in this problem, we have a trigonometric equation. So in order to do this problem, the best way to do it is to realize that this almost looks like a trig identity. So if you have the sine of 2x, that's actually equal to 2 times the sine of x times the cosine of x. And so in this problem here, we almost have this. We have sine x, cosine x. We're just missing the 2. So let's go ahead and put it there. So multiplying both sides by 2. So 2 sine x cosine x equals 2 times 1 over 4. So now the entire left-hand side, 2 sine x cosine x, is going to become sine 2x. And that will be equal to 1/2. All right, so now here is another really important strategy. Whenever you have like the sine or the cosine or any trig function of something that's not x and it's equal to a number, use this strategy. It's really powerful. So start by writing down your interval. So we know that x is less than 2 pi and greater than or equal to 0. Then you want to manipulate this. You want to make this look like what's inside your trig function. So you want to make this a 2x. So that means it's missing a 2. So you multiply each piece by 2. So 2 times 0 less than or equal to 2 times x less than 2 times 2 pi. So this piece here is going to be 0. So 0 less than or equal to 2x less than 4 pi. And to make it even cleaner, what you can do now is you can call this piece u. So we really have 0 less than or equal to u less than 4 over pi, 4 times pi. So now we can go back in here and then replace 2x with u. So sine of u is equal to 1/2. So we're looking for all of the values of u such that the sine of u is 1/2. So let's think. So the easiest angle we can use is u equals pi over 6. That's from memory. Let's go ahead and draw the unit circle and find the other answers. So here's the unit circle. And just remember that on the unit circle, cosine is the x-coordinate and sine is the y-coordinate. Because we're trying to get a positive 1/2, the other angles that we need that will be answers are in quadrant 1 and quadrant 2 because it's positive, and sine is the y-coordinate on the unit circle. So our answers have to be in quadrant 1 and quadrant 2. So we know pi over 6 is an answer. So I'm going to write that down over here. So u equals pi over 6. The other answer is the angle that's over here and has a reference angle of pi over 6. And this is pi, so you can think of pi as 6 pi over 6. So the angle that is right here, let me draw it in a different color so you see it, and I'll draw it in blue. So this angle right here in blue is 5 pi over 6 because it's 6 pi over 6 minus pi over 6. So 5 pi over 6 is our other angle. But we're allowed to go all the way to 4 pi. So what we can do is we can just add 2 pi to each of these to get 2 more angles. So you take pi over 6 plus 2 pi. That's going to give us another angle. Let's simplify this. This is pi over 6 plus, now think of 2 pi as a number over 6. So 12 pi over 6. So this is 13 pi over 6. Now do the same thing with 5 pi over 6. Take 5 pi over 6 and then just add 2 pi to that. So plus 2 pi. So that's 5 pi over 6 plus 12 pi over 6. Really beautiful stuff. And that's 17 pi over 6. It's a lot of work. And we can't add 2 pi again because then we'll go beyond 4 pi, right? So it would be 4 pi plus pi over 6, which is beyond 4 pi. So now we have to solve each one of these. So it's a little bit more work. So u, let's go back. U is 2x. So in the first case, we have 2x equals pi over 6. To solve this, you multiply by 1/2. And so we get x equals pi over 12. There is one of our answers. Boom. For the next one, we'll do u equals 5 pi over 6. And just like before, 2x is equal to 5 pi over 6. Multiply by 1/2. You can divide by 2. It's just cleaner to multiply. So x equals 5 pi over 12. Boom. The next one would be u equals 13 pi over 6. But again, u is 2x. So 2x is equal to 13 pi over 6. Then you just multiply by 1/2, multiply by 1/2. So you get x equals 13 pi over 12. Boom. Then one more, u equals 17 pi over 6. And again, u is equal to 2x. So 2x is equal to 17 pi over 6. Then you multiply by 1/2, multiply by 1/2. Boom. X is equal to 17 pi over 12. And those would be all 4 answers. I hope this video has been helpful. In this video, we're going to find all solutions of this equation. So this is an interesting equation because cosecant of 2x is really the same thing as 1 over sine of 2x. You could really think of it this way, and then you have the sine 2x right here, and then this is equal to 0. So if you set each factor equal to 0, for example, if you set sine 2x equal to 0, that's fine, you can solve. However, any value of x that makes sine 2x equal 0 is not going to work in this equation because we have 1 over sine 2x. So let's just go ahead and distribute through and ignore this fact that this could be equal to 0 because it can't, right? Because we're dividing by sine 2x. So distributing through, sine 2x times 1 over sine 2x is going to give us 1. Then minus, this will be 2 sine 2x. And then this is equal to 0. And we can solve this for sine 2x by subtracting 1 from both sides like this. So we get negative 2 sine 2x. And that's equal to negative 1. And then we can just divide both sides by negative 2. So divide, divide. That gives us sine 2x. And that's equal to 1 over 2. And we have to find all solutions for which this is true. So recall that on the unit circle, sine is the y-coordinate, so we're going to be either in quadrant 1 or in quadrant 2. Also, when you see something like this, you should ask yourself, what angle can we take the sine of that will give us 1/2? So since sine is the y-coordinate on the unit circle, it's going to be up here. So first note that the sine of pi over 6 is 1/2. And this is just from memory, right? This absolutely requires memorization. So this is something you know. You should know the ones, I guess, for like pi over 4. Those are easy because you get square root of 2 over 2 for both sine and cosine in that case. Tangent you can usually figure out if you know sine and cosine. So really the tricky ones are like pi over 3 and pi over 6. So like the sine of pi over 3, that would be the square root of 3 over 2. Okay, so in theory, once you memorize this one, you know that the sine of pi over 6 is the other one, it's 1/2, and many ways to do it. So that's going to be one angle. That's going to be right here. It's going to be pi over 6. The other angle has to be over here, right? And it will be pi over 6 less, right? It'll be pi over 6 less. And the reason I know that is that's just how the trig functions work, right? The angle here, this dotted angle here that I'm drawing, that's called a reference angle, and that angle is pi over 6. Because the trig function values of an angle and a reference angle are the same, except possibly for a sign change. And then this is pi. And we want to think of that as a number over 6. So we can think of it as 6 pi over 6. And that's what I do. And then I say, okay, because it has a reference angle of pi over 6, it's pi over 6 less than 6 pi over 6. So it's 5 pi over 6. And once you get this thinking, like once you know how to do this, all you have to do is memorize this because the other ones are easy. And from this, you can get the rest. And you can do all of this like this. And this is the minimal memorization method, in my opinion. There's other ways of doing it. People make little charts and stuff. Just bare minimum memorization. So pi over 6 is one of the answers, right? So what we do is we know that 2x is equal to pi over 6. That's one of the answers. But the thing is, if we're at pi over 6, let me use a different color. So say we're here, we can add or subtract 2 pi, right? We can subtract or add 2 pi to get back there. So this is plus 2k pi. And then to solve for x, we can divide by 2. It might be easier to see if you multiply by 1/2. In fact, you can just multiply each term by 1/2 because you could distribute it on the right-hand side. So you would get x equals pi over 12 plus k pi. And k here is an integer. You can write where k is an integer. I'm going to be really lazy and say k. And this symbol here means belongs to, is a member of, is an element of. And then I'm going to use the symbol for integers. And I believe, I don't really speak German, but I believe it's because the German word for numbers is Zahlen, I believe. I'm not really sure, but it's Z, it's a set of integers. So K is an element in the set of integers. Okay, the other one is 5 pi over 6, right? We established that. So then we would just take 2x again, right? Because that's what's here. And we set that equal to 5 pi over 6. And again, plus 2k pi, because we can add or subtract any multiple of 2 pi to 5 pi over 6, and we end up in the exact same place on the unit circle. Again, to solve for x, because we have a fraction on this first term, it might make a little bit more sense to multiply by 1/2. It makes things a little bit easier to look at. So x is equal to, so 1 times 5 pi is 5 pi, and then 2 times 6 is 12, plus, and then here we have k pi. And in all of this, k is an element of the set of integers. And that's it, we've solved it. So not really a super tough problem, but certainly a lot harder than some of the other problems that people do in trig. But still, it does require some trickery. I think a pitfall might have been for some people, I don't know, would have been, immediately setting each factor equal to 0. And then, you can solve this, and you get answers here, but those answers won't be valid because they won't check in the original equation. So something to watch out for. So it's always important to think a little bit about what's happening in the problem before you jump to solve it. And the reason I saw that is because I wasn't sure, should I multiply or should I just set each piece equal to 0? And then I thought about what cosecant was, and I said, oh, wait a minute. Well, sine can't be 0, right? So kind of a fun problem. I hope this video has been helpful to someone out there in the world. Good luck.
Solve 2 times the sine of x minus 1 equals 0 over the interval 0 to pi. Solution. So in this case, we have to solve for x, and we only have one trig function. So it makes sense to start by solving for sine x. So to do that, we'll add 1 to both sides. So plus 1, plus 1. So we get 2 sine x, and that's equal to 1. So now to finish, we'll divide by 2. So we get sine x is equal to 1/2. So the question is to find all of the values of x in the interval 0 to pi, where sine x is equal to 1/2. So one of those values from memory is simply pi over 6. And this is just pure memorization. The sine of pi over 6 is equal to 1/2. Totally worth memorizing that. Super important. Okay. So now the question is there another angle that will give us 1/2? Well, here's pi over 6. So on the unit circle, sine is the y-coordinate. So we're looking for the other angle that's a multiple of pi over 6 that is positive, right? So that means the other angle has to be here, right? Because this is positive, so our other answer has to be in quadrant 2. So that angle is 5 pi over 6. Okay, so the other answer here is 5 pi over 6. And that's it. Let me explain that again. So when you get here, from memory, you get x equals pi over 6. And the question then becomes, what is another angle that when you take the sine of that angle, you get a positive 1/2? Now you know it has to be a multiple of pi over 6. In particular, its reference angle has to be pi over 6. So the other angle with reference angle pi over 6 that gives you a positive 1/2 has to be in quadrant 2. So if this distance here is pi over 6, then this angle here has to be 5 pi over 6. So the other angle is 5 pi over 6. It takes some practice. I hope that makes sense. Solve sine x times the cotangent of x minus sine x equals 0. So we're trying to solve this trigonometric equation over this interval here, 0 to pi. Solution. You'll notice something, that cotangent is really cosine over sine. So let's go ahead and rewrite this as sine x times cotangent, which is cosine over sine. And then here we still have the sine function. And this is equal to 0. And now the sine functions cancel, right? And this is okay as long as sine is not equal to 0. So we have cosine minus sine equal to 0. So if we solve for cosine, we get that the cosine of x is equal to the sine of x. And we have to find all solutions to this equation on the interval 0 to 2 pi. So let's carefully think about the unit circle. This is basically asking us, on the unit circle, when is the x-coordinate equal to the y-coordinate? Remember, on the unit circle, every ordered pair is of the form cosine theta, sine theta. So your x-coordinate is cosine and your y-coordinate is sine. So when are they the same? Well, pi over 4, that's one place they're the same, right? And at this point, they're both square root of 2 over 2, square root of 2 over 2. And the other place is down here. This is 5 pi over 4. In this case, both sine and cosine are negative. So we have negative square root of 2 over 2, negative square root of 2 over 2. But all we care about are the angles. So the answers to this problem are pi over 4 and 5 pi over 4. And that's it. Solve 2 times the sine squared of x plus 3 sine x plus 1 equals 0. And we're looking for all solutions to this equation over this interval here. So solution.
Let's go ahead and try to factor this. So 2 sine x, and I'll go ahead and put a parentheses here, and then parentheses sine x. And let's see, 2 sine x times sine x, that's going to give us 2 sine squared. So that part's okay. Now we just need two numbers that multiply to 1. Well, let's try 1 and 1. So plus 1 and plus 1. And let's see if this actually works. The middle term and the outside term should give us this one. So, or rather, the inside is sine x, and the outside is 2 sine x. Yep, and if you add them, 2 plus 1 is 3, so it checks. Okay, so we have a product, and it's equal to 0, so we can go ahead and set each factor equal to 0. So 2 sine x plus 1 equals 0. And then over here we have sine x plus 1 equals 0. Let's go ahead and solve this one first. Subtracting 1, we get 2 sine x equals negative 1. And then finally, we'll go ahead and divide by 2. So the sine of x is equal to negative 1/2. Now here's where you have to draw on some deep, or rather not deep, but some trig knowledge. If you have this memorized, if you know that the sine of pi over 6 is equal to 1/2, then you know that the other answers, the answers to this equation, are all going to be multiples of pi over 6. So it's going to be one of these guys, pi over 6, 7 pi over 6, 11 pi over 6, or 5 pi over 6. So now what you do is you think about the unit circle, and you want sine to be negative. That means you're going to be down here and down here, right? Because on the unit circle, sine is the y-coordinate. So you want to ask yourself, okay, what's an angle that's a multiple of pi over 6? It's one of these that's down here. Well, pi is 6 pi over 6. So if you go pi over 6 more, you get to this angle here. So one angle will be 7 pi over 6. So 7 pi over 6, that's one of our angles. You might say, what about the one down here? Well, that's going to be 11 pi over 6. So 11 pi over 6. So that takes care of those two. And then here you end up with sine x equals negative 1. And again, think about the unit circle. So here's the unit circle. And this is the y-coordinate on the unit circle. So when is the y-coordinate equal to negative 1? Well, right there. And this angle here is simply 3 pi over 2. So x is equal to 3 pi over 2. And that's it. Solve 2 times cosine x plus 1 equals 0 over the interval 0 to pi. Solution. So we have one trig function. So we'll start by solving for cosine x. So we'll subtract 1 from both sides. So we get 2 cosine x equals negative 1. Then we'll divide by 2. Divide by 2. So we get cosine x equals negative 1/2. And we have to find all of the values of x in the interval 0 to pi, where the cosine of x is equal to negative 1/2. So when you see this in your mind, you want to think, okay, the cosine of pi over 3, that's equal to 1/2. That's what you want to think about. So you have to think about what other angles have a reference angle of pi over 3 that will give you negative 1/2. So what are the angles that give you negative 1/2? Well, cosine on the unit circle is the x-coordinate. So those angles have to be multiples of pi over 3, and they have to be here and here. And the reason they're here is because cosine is negative here, and this is negative. Right? If this was the positive 1/2, then the angles would have to be here and here. Okay, so the angle that's a multiple of pi over 3 here is 2 pi over 3. And the angle we want here is simply 4 pi over 3. And you can check that these are the correct angles, right? The reference angle here is pi over 3. The reference angle here is pi over 3. So the answers are 2 pi over 3 and 4 pi over 3.
Let me go over that again one more time and explain it a little bit differently, because this is tough stuff. So you have cosine of x equal to negative 1/2. So when you see this in your mind right away, you want to think, okay, the cosine of what is 1/2? Ah, well, cosine of pi over 3 is 1/2. Then you say, all right, I need an angle that's going to give me negative 1/2. So if it's going to be negative, because cosine is the x-coordinate on the unit circle, the angle has to be here and has to be here. Those are the angles. Now, the familiar angles that are multiples of pi over 3 that reside in these quadrants are 2 pi over 3 and 4 pi over 3. And so those are the answers. I hope that makes sense. Sine squared of x plus sine x minus 6 equals 0 over 0 to pi. Solution. So it looks like we have a quadratic equation in sine x. So we should definitely try to factor it. So we know it should look something like this. Because when you multiply sine x times sine x, you get sine squared x. So we need two numbers that multiply to negative 6, but add to 1. So I'm thinking positive 3 and maybe negative 2. Right? Let's check. 3 times negative 2 is negative 6. And when you add them, you get 1. Yep, looks good. So you have a product equal to 0. So we set each piece equal to 0. So sine x plus 3 equals 0. And sine x minus 2 equals 0. We can solve this one for sine by subtracting 3 from both sides. Minus 3, minus 3. So we get sine x equals negative 3. Here we can add 2 to both sides. So we get sine x equals 2. And neither of these has any solution. Well, why? Well, the sine function is bounded by 1 and negative 1, right? The maximum value of sine is 1. The minimum value is negative 1. It never goes as low as negative 3, and it never goes as high as 2. So the answer here is no solution. That's it. Solve sine squared x minus 2 sine x plus 1 equals 0, all over the interval 0 to pi. Solution. So we should be able to factor this, and if it does factor, it should look like this. Sine x, in parentheses, sine x, and in parentheses, and equal to 0. And the reason is, when you multiply sine times sine, you get sine squared. So now we need two numbers that multiply to 1 and add to negative 2. So I think negative 1 and negative 1 should work, because negative 1 plus negative 1 is negative 2. And when you multiply these, you simply get positive 1. Then you set each piece equal to 0. So in this case, we have sine x minus 1 equals 0. And then it happens again, so you do it twice. It's not really necessary in this case. Then you have sine x equal to 1. All right, so now we have to think about the unit circle. So on the unit circle, every point can be thought of as cosine theta, sine theta, every ordered pair. So you see the sine of theta is the y-coordinate. So when we're asking when is the sine of x equal to 1, you can kind of think of x as your theta. And you say, okay, when is the y-coordinate equal to 1? Well, that's going to happen right here, right? Here the y-coordinate is 1. The ordered pair is 0, 1. And the angle here is pi over 2. So our theta is pi over 2. In this case, this is our x, right? So our x is equal to pi over 2. Then, of course, we should ask, are there other answers in the interval 0 to 2 pi? But there's not. This is the only place between 0 and 2 pi where the y-coordinate is equal to 1. Right? You would have to go all the way around again, and that would put you outside the interval. So that's the final answer. Solve cosine squared x plus 2 cosine x plus 1 equals 0 over the interval 0 to pi. Solution. So we have a trigonometric equation, and it's equal to 0. So usually what you can do in these cases is try to factor. So you'll notice this cosine squared term here. So if it factors, it's probably going to look like this. So parentheses cosine x, parentheses, parentheses cosine x, parentheses, and this is equal to 0. And the reason is cosine x times cosine x is cosine squared x, right? This means the same thing. This is cosine x quantity squared. Okay, now we just need two numbers that multiply to 1 but add to 2. So in this case, I think it's going to be 1 and 1. And this will be plus and plus. And we can check, right? If you multiply the inside, you just get cosine x. If you multiply the outside, you get cosine x. If you add them up, cosine x plus cosine x is 2 cosine x. And 1 times 1 is 1. So this is the same as saying cosine x plus 1 is equal to 0. Right? You set them both equal to 0, but they're the same, so you just end up with this. Then you solve for cosine x. So cosine x is equal to negative 1. Now you have to think on the unit circle. So when on the unit circle is cosine equal to negative 1? So on the unit circle, every ordered pair can be thought of as an ordered pair of the form cosine theta, sine theta. So you see cosine is the x-coordinate. So the x-coordinate is going to be negative 1 right here, negative 1 comma 0. That's when the x-coordinate is negative 1. And the corresponding angle here is pi. So the answer here is x equals pi. Are there other answers where this is true? Yes, but they're not inside this interval 0 to pi. Right? This is 0, which is the same thing as 2 pi. This is pi over 2, and this is 3 pi over 2. So you would have to go all the way back around the unit circle to get back to negative 1. So the only answer in this case is x equals pi. I hope that made sense.